Good afternoon, class. We are looking at the final exam review covering sections 1.6 all the way to 5.4. Here's the first part of that. We've seen many differentiation formulas, reminding you of those formulas, everybody. Delta y, which is f of x plus delta x minus f of x, versus dy, which is f prime of x dx. And linearization refers to finding the equation of a tangent line. And you can just use the point slope formula. When it comes to logs, the base must be positive and it can't be 1. If we follow the arrow here, log base b of x equals y is the same as b to the power of y equals x. We have an easy time understanding the properties of logs. When we go to common log and the base becomes 10, we can translate these properties into common logs. As far as natural logs are concerned, where the base is e and we write y equals ln x. Same thing happens, understanding that with this arrow. Because logarithmic functions and exponential functions are inverse functions, they are symmetric with respect to the line y equals ln x. This is the change of base formula. Log x base b is log x over log b with any base, base a in general. If we don't have the base, that means common log. And if we put ln, that means natural log. When you take the derivative of a natural log, you simply flip it over. If it's a function of g of x, you flip it over times g prime of x by the chain rule. And if the base is different, you do exactly the same thing, and then you multiply by 1 over ln b as well to cover all your bases. These are integration formulas or anti-differentiation, the reverse process. FTC, short for fundamental theorem of calculus, has two formulas. One of them is the derivative of the integral, gives you the function back. And one of them is the definite integral, which is a number. The definite integral of a to b f of x dx is capital F of b minus f of a, where capital F prime is lowercase f of x. And the substitution rule, the integral of f of g of x times g prime of x dx, where you let g of x be represented by u, therefore g prime of x dx is du. It's the integral of f of u du is known as the substitution method, everybody. We want to differentiate this, so we are going to rewrite this by bringing this to the power of 1/2, bringing it up and make a negative exponent. Now the answer is 4 times negative 1/2 times the same expression to the power of negative 1/2 minus 1. We are looking at the extended power rule. And finally, by the chain rule, the extended power rule, the derivative of the inside, which is 2x. 4 and negative 1/2, the product is negative 2, with 2x becomes negative 4x. You repeat this one to the power of negative 3/2. And this goes down, makes it positive 3/2, or you write it as a square root. So this is 3/2. This is 3, everybody, to the power of 3/2 in the denominator. That means square root of x squared plus 3 to the power of 3. That's the meaning. Y equals 2x plus 3 over x minus 8 to the power of 5 uses the extended power rule. First, we need 5. Then we need the expression to the power of 5 minus 1 or 4. And this is f, this is g. We are going to use the quotient rule, f over g. which requires f prime g minus g prime f over g squared. So the derivative of the top is 2 times x minus 8. Minus the derivative of the bottom is 1 times 2x plus 3, and you just write the bottom squared. You distribute, you get 2x minus 16, you get minus 2x minus 3, and 2x cancels out the negative 2x. You get negative 19. And you can go to the final answer. However, just to make sure we understand what this is 2x plus 3 to the power of 4, as well as x minus 8 to the power of 4. Makes it easier now when we want to write the final answer. In the numerator, we have this one, and this one. The product of these two is negative 95, 2x plus 3 to the power of 4. The product of these two is x minus 8 to the power of 4 plus 2, or 6. So we write this to make it easier to understand the final answer. We want to use implicit differentiation, and we notice this is 4x squared times y. We put a raised dot, and we use the product rule on that. 4x squared gives you 8x times y, plus y gives you y prime, or dy dx, times 4x squared. 2y squared is 4y prime. Any number such as e results in 0. We're practically done. We can move this to the right. And these two, we take a common factor of 4y prime. We divide both sides by 4 times x squared plus y. And we get negative 2xy over x squared plus y as the final answer. Whenever we want to differentiate a sinusoidal function, when we read this, we read it as cosine, and we pause. Just pause. Cosine. The answer is negative sine. But negative sine of what? You have to have an argument, which is the same argument, 3t to the power of 4. By the chain rule, now we need the derivative of the argument, which is 12t cubed. We put that in front. We get negative 12t cubed sine of 3t to the power of 4 as the final answer. A small rock is dropped into a lake. Circular ripples spread over the surface, with the radius of each circle increasing at the rate of 3/2 feet per second. Find the rate at which the area of a circle is changing when the radius is 4 feet. So this is a circle. This is a radius. This is the diameter, which is 2 times the radius. If you go around it, it gives you the circumference, which is 2 pi r. And if you want the area, is pi r squared. And that's exactly what we need here. The area equals pi r squared. So this sentence tells us that dr dt is 3/2 feet per second. We want dA dt when r is 4. This is the translation of the question with the basic formula, A equals pi r squared, from geometry, algebra, you name it. We want to differentiate this, and remember, it's the r dt here, or just look at the units. That means the t is the independent variable, and in essence, you are dealing with the Leibniz's notation. Dy dt is dy du dt. So you want the dA dt, you write pi, and then you differentiate r squared, which is 2r dr dt. You put the 2 in front. And now you're ready to replace the r with 4, dr dt with 3/2. These 2 cancels out the 2. You get 12 pi precisely. This is an approximation. You always want to write the exact answer. units of the area over the units of time, square feet over square feet over seconds, and you want to write the units as always whenever you're dealing with board problems. Find dy dt for this equation. The moment you see dy dt, that means t is the independent variable. And well, what it means is that the derivative of y is dy dt, the derivative of x is dx dt. We are going to differentiate this using the extended power rule. We start with number 4. Then we write the parentheses, 5x plus y to the power of 4 minus 1 over 3. Then by the chain rule, we need the derivative of the inside, which is 5 dx dt plus dy dt. Minus x minus dx dt, and any number results in 0. You could solve for dy dt. There is no reason for that. You're just evaluating. So plug in dx dt is 3, x is 2, y equals -9. Plug in and find the missing dy dt. 10 minus 1 minus 9 is 1, and cubed is still 1. This is 15. So this is what we get. We are going to distribute. We get 60 here. And 60 and -3, they add up to 57. We're going to move it, make it -57. We're going to divide by 4. And dy dt becomes minus 57 over 4. We're going to move on. A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet per minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building. You have to have a drawing. You have to have a setting and define your variables. So we have the wall or the building, we have the ladder. It moves this way, creates this shape. And as it moves this way, it comes down. And this ladder has a fixed length of 20 feet. It's not changing. As it moves this way, it has a speed or rate of dx dt is 2 feet per minute. As it moves down, it has a speed or rate of dy dt, which we don't know. We want to find it at the moment when the base is 12 feet from the building. That means x is 12 feet. This is how you write this properly. And so, of course, we should know the Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus y squared equals 20 squared. So the drawing and the given here gives us the synopsis of everything that is available to us. So we are going to differentiate 2x dx dt plus 2y dy dt equals 0 because 20 squared is a number, although it's 400, makes no difference. We have everything we can plug in. We notice y is missing. So when at the moment that x is 12, we can find the y. So this is 400. This is 144. Subtract. And you get 256. Y squared is 256. Y is plus minus 16. We just keep the 16 only. And now we are ready to plug in. 2 times x, which is 12, times dx dt, which is 2, plus 2 times y, which is 16, times dy dt, which is missing, is 0. And we get 48 plus 32 dy dt. We are going to move this, and we make this equals 48. negative, of course, and we are going to divide both sides by 32. We get negative 3/2 feet per minute. X is increasing, the x dt is positive, y is decreasing, the dy dt must be negative, and it is. How do you find limits? You just plug in and observe. If it gives you a number, you're done. If it gives you 0 over some number, it's 0 and you're done. If it's a number over 0, it's infinity or negative infinity. I want to make sure we understand what's happening here. When you divide a number by 0, they used to say undefined, but it blows up either to infinity or negative infinity. The reason I say that, because every number, if it's positive, both sides are positive. If it's, I don't know, negative, both sides are negative. 0 is the only number the left side is negative. This is negative and this is negative. 0 is the only number that the left side is negative and the right side is positive. So it changes sign. That's why you have to further investigate. However, in calculus, most of the time we end up with one of those 0 over 0, infinity over infinity, or infinity minus infinity, all of which are considered indeterminate. And that means you have to figure out how to fix the problem. And here's an example. We want the limit of 2x squared plus 8x over x squared minus 16 as x approaches infinity. And if you plug in, you do get infinity over infinity, everybody. If you plug in, you get infinity over infinity. The technique is when x approaches infinity, you divide by highest degree term in the denominator if it's a rational function, highest value in the denominator if it's not a rational function. So when you do that, the first one becomes 2, this one goes to 0, then x squared over x squared is 1, this goes to 0, and you get 2. However, if you can factor, it really makes life easier, and we can factor this such that we can drop the common factor of x plus 4. If you deal with that, the same thing, x is approaching infinity, you divide by highest degree term in the denominator x, and that gives you the same answer, 2, as expected. If we take a limit of this expression as x approaches negative 4, if you plug in, everybody, you get 0 over 0, and the technique is factoring. And since we already have the factored 4, you're going to use that. And now if you plug in negative 4, you get minus 8 over minus 8, which is positive 1. This one, when x approaches 0, actually, even if you deal the way it's given and you don't change anything, the numerator becomes 0. The denominator is negative 16. If you deal with a factored format, you get 0 over negative 4. Both of them result in 0. So it doesn't make any difference. However, when you have x approaching 4, if you just look at number 4, what happens, you want to look at the factored form. If you plug in 4, you get 0 over 0. I want you to know that. If you plug in 4, you don't get 0 over 0. The denominator becomes 0. My apologies. And so when the denominator is 0, it's important to see from the left or right. So let's look at the factored format. It makes it easier. If you look at this one and you just are looking at 4 only, you get 8 over 0, everybody. And if you look at this one, also you get 8 over 0. However, this is 4 from the left. 4 from the left, you can think of it as 3 or closer number like 3.9 minus 4 results in minus 0.1. We want this sign, so it's 8 over 0 from the left. and that makes it negative infinity. However, if we look at this case, 4 from the right would be like 4.1 minus 4 and makes it 0.1 or makes it positive. That means 0 from the right. And positive over positive is positive infinity. So again, this is positive number over negative, that makes it negative infinity. This is positive number over positive number, makes it positive infinity. That's why you have to figure out the 0 from the left or right. In this case, if you plug in infinity, what happens? You should know a to the power minus m is 1 over a to the power of m. Therefore, e to the power minus t is 1 over e to the power of t. And because t is approaching infinity, makes this a 0. And so 12 over 4 or 3 is the final answer. In this case, if t goes to infinity, e to the power of t goes to infinity, the denominator goes to infinity, and the answer is 0. In this case, I want you to look at part A and notice if you replace the t with infinity here is the same as replacing the t here with negative infinity. These two are identical as a result. See, this is infinity, this is minus infinity. This is e to the power minus t, is e to the power positive t. And we end up with the same answer as part A, number 3. In this case, if you let t be 0, you get e to the power of 0, which we should know it's 1, and we get 12 over 4 plus 3 or 7. So it's good to compare and contrast all of those and see the changes. Let's switch gears and let's differentiate. To differentiate, I'm going to bring this up and to the power of negative 1. So the answer is 12 times the exponent negative 1 times the same thing to the power of 1 less. That means n minus 1. That means minus 1, minus 1, or minus 2. And then the chain rule says I need the derivative of the inside. As you know, is 3e to the power of t. Now, 12 and negative 1 minus 12 times 3 minus 36 e to the power of t. This goes down and takes the positive exponent. I'd like you to see all these questions side by side. If we plug in 5, we get 0 over 0. If we plug in negative 4, we get 0 over 0. If we plug in 0, all of these will result in 0 over 0. So what's the technique? The first one is factoring. And if you plug in, you get 10 over 5, which is 2. You're dealing with a complex fraction. The technique is LCD. If you multiply by LCD, the denominator, you keep it as a product. The numerator becomes x plus 4. And if you plug in, you get negative 1 over 16 as the final answer. Whenever you have a square root and the result is 0 over 0, you use conjugate a minus b times a plus b results in a squared minus b squared, which means we're going to write the same thing with this b changes plus, but you have to multiply and divide by it, because you can't just divide by or multiply by anything you want. You can multiply by 1. The denominator is unchanged. You keep it as a form of a product. The numerator, a squared minus b squared. This gets squared, comes out as 1 plus h, minus this gets squared, gets 1. 1 cancels out the negative 1. H cancels out the h. The numerator becomes 1. And when you plug in 0, the denominator becomes 1 plus 1, which is 2, or 1/2 is the final answer. To take the limit here, if you plug in infinity, I hope you recognize you get infinity at top and infinity at the bottom with the -3 in front makes it negative infinity. So infinity over negative infinity, which is indeterminate. And although it's not a rational function, because t is approaching infinity, you use the same technique. You divide by highest value in the denominator, which is e to the power of t. Divide everything by that and write the simplified version. As you can tell, since t goes to infinity, e to the power of t goes to infinity, and so this goes to 0, this goes to 0, you get positive 1 over -3 or negative 1/3 as the final answer. We want to find the derivative of this function. We notice it uses the product rule. We're going to put a raised dot here, and then this is f times g. So we need f prime g plus g prime f, which f prime becomes itself e to the power of 2x times 2. And then this is f prime g times ln x, plus the derivative of ln x is 1 over x times e to the power of 2x. As you can see, between the two, e to the power of 2x is in common. So this gives you 2 ln x, this gives you 1 over x, and you're done. Log base 5 of x squared plus 1. You want to decompose it. There's nothing you can do. So you flip this over. You get 1 over x squared plus 1. By the chain rule, you need the derivative of that. So we are here, which is times 2x. And you look at the base. If the base is e, we are done. It's not. So 1 over ln b, 1 over ln 5. Now combine it, and you get 2x over x squared plus 1 times ln 5. ln of 2x over 2x plus 1, you want to decompose that. Otherwise, you have to flip this over and then take the derivative using the quotient rule. Not a good idea. I'm going to do it in 2 steps. And this is ln of the top minus ln of the bottom. And the top, you can write it as ln of 2 plus ln x. ln2 is a number, the result is 1. ln x is 1 over x minus, flip this over, 1 over 2x plus 1, and then times 2 by the chain rule. Now notice the common denominator is x times 2x plus 1. And so you're going to say 1 times 2x plus 1 minus 2 times x. And the 2x and negative 2x cancel each other. The numerator has only 1. And the denominator has x times 2x plus 1. And we are done. Find an equation of a tangent line to the graph of this function. F of x is x squared minus 3x plus 1 at x equals 4. So to find a line, we need the slope. So we take the derivative. F prime is 2x minus 3, which is not the slope. When you plug in, number 4 becomes the slope. 2 times 4 minus 3 makes it 5. So we have this slope. We also need a pair. At x equals 4, when you plug in, you get 16. Minus 12 is 4, minus 1 is 3. And so we have the pair, we have the slope. We use the point slope formula. So y minus y1, namely 3, equals m5 x minus x sub 1, namely 4. And we distribute, we get the following. Y equals 5x minus 17 is the final answer. A doctor prescribes a 300 milligram drug to be taken every 12 hours. Just before each tablet is taken, 40% of the previous amount of the drug remains in the body. Write the expression for Q sub n plus 1 in terms of Q sub n and the rest of. So we want to write the given to make life easy. And because this is Q, we have to look at the formulas that are here and change B to Q. So first of all, the given B sub 0 becomes Q sub 0 or A 0 because we're dealing with patients. C is the amount of constant a doctor prescribes this much, so 300 milligrams. That would be the amount of constant. Or C, this is the time step. Important, doesn't enter the equation. And R, 40% of the previous amount remains. What remains in the body is the R, the ratio, the percentage. So we write Q sub 0 or A 0, C is 300, R equals 0.4. And now it makes life easier. Instead of, look at this formula, instead of B, we're going to use Q. And because we wrote the given, we are going to replace the R with 0.4, C with 300, we're done. So writing the given helps. For this one, we're going to go with this formula. And because it says QB changes to Q. Now, go back to the given and plug in. This is 0, R is 0.4, C is 300. Anything times 0 goes away, becomes 0. This is 0.6. So this is 300 divided by 0.6. Or 3,000 divided by 6, or 500. So how much drug is left after the 5th tablet? Set n equals 5. And evaluate it. We get 494.88 milligrams. As always, when you're dealing with word problems, write the units if units are given. Always write the units, everybody. What about the limit? You just have to take the limit of the expression we just found. As you recall, when n goes to infinity, 0.4 to the power of n goes to 0, because this number is between -1 and 1. So when this goes to 0, you get 500 milligrams of medication. And we're done. We have this function and we want to differentiate and we want to integrate. The reason I want to do that because I want to remind you of something that, sometimes students make a mistake. When it comes to exponentials and sinusoidal functions, exponentials, when you differentiate, you multiply by negative 0.2, you multiply by this k, if you will, okay? So we get 4 times negative 0.2 and itself, e to the power negative 0.2x. Sine, the derivative is cosine, so minus cosine. And you rewrite this as negative 0.8 e to the power minus 0.2x minus cosine. Now, to integrate this, we're going to put a dx next to it. And again, in the case of a differentiation, we multiply by this. Now, in the case of integration, we're going to divide by this. Okay, we're going to divide by this. Now, the derivative of sine is cosine, but the integral is negative cosine. Okay, negative cosine. With this negative makes it positive cosine, and of course, on a constant. Now, this is the same as 40 divided by negative 2, which makes it, which makes a negative 20. And we're done. Now, we're going to look at the same question. And what we are going to do, we are going to add an initial value, f of 0 equals 20, which means when x is 0, f of x or y is 20, and we want to find the constant. So let's see what happens. E to the power of 0 is 1, so this is minus 20. Cosine 0 is 1. Negative 20 and 1 is negative 19. Move it to the other side, becomes positive. C becomes 39. This is the function. So what you're looking at is a general solution here. And over here is a particular solution. Meaning, we had a family of functions, infinitely many solutions. This is called indefinite integral. And this one is a function, one of those with the help of one pair. To integrate, we are going to change this to x to the power 1/2. And we're going to make up two fractions, x over x to the power 1/2, 1 over x to the power 1/2. This has exponent 1. So when you do the division, becomes x to the power 1 minus 1/2, which is positive 1/2, and this is x to the power of negative 1/2. And now you're ready to integrate using the power rule. One over 1/2 plus 1, x to the power of 1/2 plus 1, plus 1 over negative 1/2 plus 1, x to the power of negative 1/2 plus 1 on a constant. You know 1/2 plus 1 is 3/2. Negative 1/2 plus 1 is 1/2. The reciprocal of this is 2/3. The reciprocal of this is 2, and you're done. We're going to do substitution here. So I'm going to remind everybody, look for a function u equals g of x anywhere in the integrand, and its derivative du, or g prime of x multiplied by d of x. So the integral of 2x parentheses x squared plus 5 to the power of 30 dx. This is a polynomial, this is a polynomial. You have only polynomials. The more complicated one is a choice of u, which is x squared plus 5. You know its derivative is 2x. Therefore, du is 2x dx. Move the 2x next to dx because it becomes clear. You have u to the power of 30 times du. And it uses the simple case of a power rule, 1 over n plus 1. That means 1 over 30 plus 1 or 1 over 31. U to the power of 31 on a constant. Replace the u and we are done. 1 over 31 x squared plus 5 to the power of 31 plus a constant. And as always, if you differentiate the results, you get the same thing back without the dx. Anytime you have a rational function or a fractional function, first you have to simplify if you can't, put it in lowest term. If not, the denominator is a choice of u. When u is 5 plus e to the power of 2, you know the derivative is e to the power of t, therefore du is e to the power of t dt. dt belongs to the numerator, dx belongs to the numerator, they never belong to the denominator. We are going to rewrite it so it becomes clear. We have du over u. And this is a simple case of a natural log. Replace the u, you get ln of the absolute value of 5 plus e to the power of t plus c as a final answer. If you want to get rid of the parentheses, the brackets, the absolute value sign, and change it to parentheses is fine because the expression is positive. This one we can simplify because b squared minus 4ac or the denominator is 2 squared minus 4 times 1 times negative 1, which is 8. It's not a perfect square. It can't be factored. So that's the choice of u. Its derivative is 2x plus 2, or 2 times x plus 1. Du becomes 2 times x plus 1 dx. We are going to rewrite it such that dx is at top. So it becomes clear everything is in order except number 2 is missing. And remember what I told you about number 2. In many texts, they solve for dx. The fastest way is say, since it's a number, I'm going to put the 2 here, undo it with 1/2. And by the way, both of them are outside or inside, makes no difference. The reason I put this one inside, so you see this is du. The reason I put this outside, because it has no bearing. It just keeps on happening again and again. So you have this part, which is identical to this part. It's half of a natural log and a constant. Replace the u and you're done. You have to keep the absolute value because this expression could be positive, it could be negative. Now, what I want to look at, I want to look at this case. If you have the reciprocal of this one or reciprocal of this one you do the long division, this one you make up 2 fractions, this one, which is 5 e to the power of negative t, and this one, which is 1. And the point is you do not need to use substitution. So this one is 5 divided by negative 1 or minus 5 e to the power minus t. This is t and a constant, and you're done.